Good morning, students. In previous class, we have seen about how to solve problems on friction, wherein the block was kept either on an horizontal surface or it was kept on a inclined surface. In today's class, we will see how to solve the problems when the blocks are connected to each other by means of a string. Just refreshing your memories, we have seen that to solve the problems on friction, we have to draw a free body diagram. And for free body diagram, we need to show all the applied forces, self weight vertically downwards, then reaction from contact surfaces, which will be perpendicular to surface, and the direction will be from surface to the body. And the last one will be the frictional force, which will be acting in the direction opposite to the motion of the body. So with this quick revision, let us move forward to the next question, which says two blocks A and B, 500 Newton and 750 Newton respectively, are connected by a cord which is passing over a frictionless pulley as shown. Mu between block A and the plane is 0.4 and between block B and the plane is 0.3. Determine the force P required to apply it to the block to produce the impending motion of block B down the plane. So in this type of problems, the important thing is to determine the direction of motion for both the blocks so that we can make the friction force correctly. So to avoid that confusion, what I will do is I will mark the direction of motion of both the blocks in the dotted line in the diagram. B will be moving downwards, so motion of B will be down. So I will make a dotted line towards downside. And if you observe carefully, once B goes down, and because block A is attached to the string with block A motion will be towards up the plane. So this I have just made the direction of the motion of the block so that it is easy for us to make the direction of the friction force. Okay. Now starting with the free body diagram of block A, I will first separate it from all the surfaces, from all the contact surface. Then showing the forces. So as we have discussed, the thread by which it is connected will be shown as a tensile force in the cable and it should be shown away from the body. So I will make a tensile force here and going away from the body. Then we have to make self weight. So self weight should be made perpendicularly, vertically downwards. So weight value for block A is given as 500 newtons. So I will write here 500. Then reaction from contact surface. So as you can see in the diagram, the surface is inclined like this. Hence the reaction will be perpendicular to it, will be somewhat like this. So just transferring this N1 into the free body diagram, I will write N1 here. So this is your reaction from contact surface. And as we have discussed, the motion of the block A will be up the plane. The friction force on block A will be down the plane with a value of 0.4 multiplied by N1. So this completes our free body diagram of block A. But before proceeding towards the applying condition of equilibrium, we have to resolve the forces. So let us say if I consider the changed coordinate system, like considering this as x and this as y, what I will get is I have to resolve the inclined force, which is the weight. So resolving it into draw one line parallel to x and one line parallel to y axis, and the angle we have seen that as this force is vertical, the angle made by the force will be here 50 degrees. The angle made by plane will be equal to the vertical component of the force. So this will become 500 cos 50 and this will become 500 sin 50. Now our free body diagram is ready to be applied for conditions of equilibrium. So the first condition of equilibrium I will apply summation of Fx is equal to 0. That is adding all the forces in x direction. So I will get T, that is going right side, so positive, minus 0.4 N1 and minus 500 sine 50. This all should be equal to 0. Now just rearranging the terms, taking the unknowns on one side and number on one side, I will get T T minus 0.4 N1 is equal to 500 sine 50. Let this be equation number 1 because we are not getting the answer. Now, going for the next equation, that is summation of Fy should be 0. That is adding all the forces in y direction. I will get N1 minus 500 cos 50 is equal to 0. And on solving this equation, I will get, therefore, the value of N1 is equal to 500 cos 50, which will come out to be as 321.39 newtons. Now, substituting this value in equation 1, here I will get, therefore, value of T is equal to 511.57 newtons. Just we need to substitute in equation 1 the value of N1 and we'll get the value of T. So this completes the entire calculation part of the free body or the body A. Now, going to the second body of the given equation, that is body B. Again, same procedure. First, I will draw the free body diagram for B. So, isolating the body from all the contact surfaces. The first force which is there acting on the body is the applied force, which is given as to be as P. So, I make it as P here. Then there is also one cable connected with B, and we have assumed the tension in that cable is T, and that tension here you also should be shown away from the body. So I will make it as T away from the body. So these are the applied forces or considered to be as applied forces. The second force which we show in the free body diagram is the self weight. So self weight will act vertically downwards, and the value given to us for this block B is 750 newtons. So this will be 750. Then we have reaction from contact surface. So from the diagram, you can see that the surface here is inclined. Hence, the reaction will be perpendicular to it like this. So transferring it on the free body diagram, I will get N2 like this. Then regarding the friction force, as we have discussed that block B will be going down the plane, friction force will be going up the plane with a value of 0.3 multiplied by N2 because the friction coefficient of friction between B and block is 0.3. Now, if I consider the coordinate system like this, considering this as X and this inclined as Y, the only inclined force in this particular diagram is the self weight. So just resolving it into two parts, drawing one line parallel to Y and one line parallel to X. That is the component of the forces. And the angle, as we have seen that this force is vertical, hence the angle made by the plane, that is 30 degree, will be made by the vertical component of the force. So in this case, this is the vertical component of the force. So this angle will be 30 degrees. So this will become 750 cos 30 and this will become 750 sin 30. So now our free body diagram is ready to be applied for conditions of equilibrium. So starting with the first condition of equilibrium, that is summation of Fx should be 0. I will get minus T plus P plus 750 sin 30 minus 0.3 N2 should be equal to 0. Let this be equation number 2. Now, writing about summation of Fy is equal to 0. So I will get the value of N2 as N2 as it is going upward, it will be positive minus 750 cos 30 should be equal to 0. So from here, I will get the value of N2 as 649.51 newtons. Now what to do is we got the value of n1 and n2 and also t. So just substituting these values in equation 2, like t will be coming here. The value of n2 will be substituted at this particular point. So on substituting the values, I have only unknown in this entire equation, that is p. So just by solving the equations, I will get the value for p as 331.43 meters. What you have to do is just substitute the values of t and n2 at the respective places and you can get the answer for p. So this completes the solution for the blocks connected with each other by means of a thread. So the point worth noting was it is exactly similar to what we have solved earlier. Just the cases there are two blocks, earlier it was one blocks. And the important thing again I repeat is drawing the free body diagram correctly. So if you draw the free body diagram correctly, there are less chances of getting your answers wrong. And if the free body diagram is wrong, the entire solution will be guaranteed wrong. So you have to be careful while preparing the free body diagram. Proceeding further to the next question. The question says like this. Determine the force P required to cause the motion to impend. Take masses. Again, an important part. Here the question, the mass is given, not the weight, of blocks A and B are 8 kg and 4 kg respectively. Coefficient of static friction between the sliding surfaces is 0.2. Assume the pulley to be smooth. The force P and the rope are parallel to the inclined plane. So that means this angle and this angle will be same. So again, before proceeding to the numerical side, let us first discuss on the direction of motions for both the blocks. So as it is seen that from the diagram that force P will try to move block A towards left side. So I will make the direction of force, or sorry, direction of motion towards left side for motion for block A. And as you can observe, as it is connected through the string to block B, as block A will go down, block A will try to move up the plane. So these are the direction of motion for block A and block B, which will be useful for us while drawing the free body diagram when we take the friction force into account. Okay, starting with the solution and drawing the free body diagram of both the blocks. So starting with block A, so I will first isolate it from all the contact surfaces. So this is the isolated block. The first thing which we show is the applied force. So there is applied force P given in the question, and also it is connected by a thread. So as discussed earlier, the thread will be shown. The force in the thread will be shown as a tension, and it will be going away from the body. So it will be shown like this as a tension T in the cable going away from the body. Then self weight acting vertically downwards, and the weight is given. In the question, we are given mass, not the weight. So we have to convert it into weight by multiplying it by 9.81. So it will be 8.8 multiplied by 9.81. Then reaction from contact surface. So as you can see in the diagram, the surface is inclined at angle 30. Reaction will be perpendicular. It will be like this. So converting or transferring the reaction into free body diagram, I will get N1 like this, which is perpendicular to surface. And now regarding the friction force, as we have discussed that the block A is moving towards left side, friction force will be moving towards or will be shown towards right side with a value of 0.2 multiplied by N1. Now if I consider the X and Y axis like this part, X and Y, the only inclined force here is the self weight, which I can resolve it into X and Y components like this. Now, as the force is vertical, the angle made by the plane will be shown with the vertical force. So this angle will be shown as 30 degrees. So this will be 8 multiplied by 9.81 cos 30, and this component will be 8 multiplied by 9.81 sin 30. Now our free body diagram is ready to be applied for conditions of equilibrium. So if I apply the first condition, that is summation of fx should be 0, what I will get is t plus 0.2 n1 minus p, and then minus 8 into 9.81. This 8 into 9.81 comes out to be as, that is 78.48. All should be equal to 0. Let this be equation number 1. Similarly, if I apply summation of fy is equal to 0, so I will get the value of n1, that is going upward, minus 8 into 9.81 again is 78.48. So I can directly write here, it is 78.48 cos 30. And on solving this equation, I can get the value of n1 directly as n1 is equal to 67.96 newtons. Now, coming to the second free body diagram, that is free body diagram for block B. So first of all, I will isolate the body B from all the contact surfaces. So this is body B. First is the applied force. There is no direct applied force on body B, but there is a cable which is connected. So cable will be considered, or the tension in the cable will be considered as the applied force going away from the body. So this I will show as the tensile force in the cable. Then the self weight. Self weight will be acting vertically downwards. Weight here is not given, we are given mass. So I will write 4 multiplied by 9.81, converting into newtons. Then reaction from contact surface. As we can see in the diagram, the surface, contact surface is inclined at some angle 30°. So the reactive force will be like this, perpendicular to the surface. Converting or transferring it into the free body diagram, I will get N2 somewhere in this direction, which is perpendicular to surface. Also earlier we have discussed that as A block is moving downward, B will try to move up the plane. Hence, the friction will be going down the plane. So this will be 0.2 N2. So this completes our free body diagram. And now if I consider the coordinate systems like this, X and Y, the only inclined force in this entire free body diagram is self weight. So I will resolve it into two components, X and Y. And as this is a vertical force, the angle made by the plane, that is 30° will be shown with the vertical component. So this will be shown as 30°. So here it will be 4 into 9.81 cos 30. And this will be 4 into 9.81 sin 30. When I calculate this value of 4 into 9.81, I will get the answer as 39.24. Similarly, here also I will write 4 into 9.81 is 39.24. Okay. Now applying the conditions of equilibrium, that is summation of fx should be 0. So I will get t minus 39.24 cos 30 minus 0.2 n2. This all should be equal to 0. Let this be equation number 2. Similarly, if I apply summation of fy is equal to 0, I will get n2 minus 39.24 cos 30 equal to 0, or I can directly get the answer as n2 is equal to 33.98 newtons. Now, Substituting this value of n2 in the equation made above, that is equation number 2, what I will get, the only unknown in this particular equation is t. On solving this equation, I will get the value of t as 26.42 newtons. What you have to do is just substitute the value of n2 in equation 2 and get the answer for t. Now, we have the answers for t and n1. So what I will do is substitute the value of t in equation 1 along with the value of n1 here. So the only unknown, if you see in this entire equation now remains is t. So just substitute the value of n1 and t in equation 1. I will get the value of p as 0.772 newtons, which is the required answer. So in the question it was asked, what is the force P required to cause the motion to impede? So the answer will be the force P required to impede the motion is 0.772 newtons. So with this, we have completed the problem on connected bodies, wherein the body A was connected with the body B. Hope you are getting the concepts and the problems which are being solved. So on that note, let us move further to the next question, which says block A of weight 2000 Newton is kept on a plane inclined at 35 degrees. It is connected to weight B by an inextensible string passing through over a smooth pulley. Determine the weight B so that the B body just moved down, and value of theta is given to us as 20 degrees and coefficient of friction is given to us 0.2. So as we normally do, first I will decide the direction of motion for both the blocks. So as it is given to us in the question that block B will be moving downwards. So I will make the direction of motion of B downward. And because B is moving downward and it is connected by a cable through block A motion will be impending towards up the plane. So these are the directions of motion for block A and block B. Now, starting with the free body diagram of block A. So first of all, I will isolate the body from all the contact surfaces. Then applied force. So we are given that block A is connected by a rope or a cable. So that will be considered as the tension in the rope. So I will make it as T. Then self weight will be acting vertically downwards. Then reaction from contact surface. As from the diagram, it can be seen that the surface is inclined at this particular angle. Hence, the reaction will be perpendicular to surface. Transferring this reaction into free body diagram, I will get the direction of N1 something like this, which is perpendicular to surface. And then finally, the friction force, as the block A is moving towards up the plane, friction force will be acting down the plane with a value of 0.2 N1. Now, as we consider the coordinate system like X and Y like this, there are two inclined force now. One inclined force is T and the other inclined force is the self weight. So resolving it, what we do is draw one line parallel to X axis, that is resolving it into X and Y directions. Similarly for weight, I will resolve it into X and Y directions. Now regarding the angles, as this force is vertical, that is self weight, the angle will be made by the vertical component of the force. So this I will write as 35 degree here. So this will be 2000 cos 35 and this will be 2000 sin 35. Now regarding this T, it is directly given that it is making angle theta with respect to this axis, and the value of theta is also given to us as 20 degrees. So this component will be termed as T cos 20 and this vertical component will be termed as T sin 20. Now our free body diagram is ready to be applied for conditions of equilibrium. So the first condition I will apply is summation of fx equal to 0. So for fx, I will write minus 0.2 n1 minus 2000 sine 35 equal to 0. Taking all the unknowns on one side and number on one side, that is, I will get t cos 20 minus 0.2 n1 is equal to 2000 sine 35. Let this be equation number 1. And when I apply summation of fy is equal to 0, I will get n1 plus t sine 20 minus 2000 cos 35 is equal to 0. Just rearranging the terms, I will get t sine 20 plus n1 is equal to 2000 cos 35. Let this be equation number 1 and 2. Now, just observing equation number 1 and 2, there are two unknowns. One is t and one is n1. And there are two equations available with us. By solving this both equations simultaneously, I will get the answer for t and n1, which comes out to be 1462.96 newtons, and n1 is coming out to be as 1137.93 newtons. So this completes the free body diagram and the solution for body A. Now let us draw the free body diagram for body B, because in the question it is asked for weight of body B. I will also need to draw free body diagram of body B. So considering body B here, as there is no applied force directly, but there is a cable which is passing over through pulley towards A, and we have considered the tension in cable as P. So I will show it here also away from the body. Then self weight, which will be acting vertically downwards, which we are required to find out. So let us say I will assume that this weight is WB. Now, as this body is in air, there is no contact. So there is no question of contact reaction, and because there is no contact of the body with any other surface, there is no question of friction force also. So this completes the free body diagram of body B. Just applying the condition of equilibrium, summation of Fy is equal to 0, I will get T minus Wb equal to 0, or I can get Wb is equal to T, whose value is 1462.96 Newton. So this completes your required answer. In the question it was asked to find the weight of B. So answer is weight of B is 1462.96 newtons.